I've started the recording, everybody. I've started the recording. Yeah, it's being recorded. It's being recorded. Yes, yes, it is. It is. Okay. So, um, sir, please, you are so. Or nahi, bache. Nahi, please, please, please. Let's just focus on chemistry for now, and then we can focus on other things later on. Yeah, because we're here to study chemistry, not to talk about me. Okay, sounds good. Okay, Prada, Gucci, Prada. Okay, let's start. So, today is officially the first class for your O level IGCSE chemistry, and hopefully, you guys are gonna enjoy it because it's roughly not related to your syllabus. But if you understand today's class, you'll be able to understand or get an idea about what chemistry or science actually is, right? So, it's not directly related to your syllabus, but some aspects of it should be known to you guys, and if it's known to you guys, things are going to be very simple. Yeah, so without further ado, let's just start. Okay, now today's class is an introduction to chemistry, and you could roughly say that it's an introduction to science, just a fun little discussion to kind of get a hang of what chemistry really is, and to kind of get an idea of the bigger picture. If you understand the bigger picture, then it's easier to zoom into other things. Wait, let me also turn the AC on, because okay, yeah, it's getting hot. Okay, so broadly speaking, your entire chemistry revolves around the concept of an atom. Literally, that's the entire idea behind chemistry. It's the atom. And does anybody know what an atom is? Does anybody know what an atom is? Yes, I'll take your suggestions. The recordings are going to be uploaded onto YouTube. But does anybody know what an atom is? Just don't raise your hands, just write it in the chat box. The basic unit of matter. Yeah, that's nice. Yeah, that's how I like to define it as well. Sir, the smallest particle. Okay, so some of you guys are saying, sir, atom is the smallest particle. You've studied that from your elementary schooling. Some of you are saying that atom is the tiniest particle, tiny particle. Atom makes up everything. Some of you guys are saying atom makes up everything and whatnot. But later on, you'll realize that these definitions, it's the smallest particle. We know that there are smaller particles than the atom. You have protons, electrons, and neutrons, and then they are also further subdivided into smaller particles. So an atom is not, in fact, the smallest particle, and therefore, the students who are saying that atom is not divisible, that's also wrong. Why is it wrong? Some students have studied this in their elementary schools, and they're saying that atom is not divisible. And not divisible means that you can't get a smaller particle than an atom. But this idea that you've studied in your elementary school, this idea is wrong, because you would realize that you have protons, electrons, and neutrons, and then there are further smaller particles than the protons, electrons, and neutrons. And you'll study more about them as we move on with the course content, right? But the way I like to define an atom for O-level IGCSE, and later we will change this definition, but the way I like to define an atom is, I like to define it as the basic unit of matter. That's how I like to define an atom. It's the basic unit of matter. Now, some of you guys may get confused. What do you mean by basic unit of matter? What does this mean? It's very easy to understand an atom once you have a clear understanding of what matter is. In order to understand an atom, you first of all need to understand what in the hell is matter. Now, scientists, what they wanted to do was, and what humans wanted to do in the olden days, was that they wanted to categorize things. They wanted to harmonize things. They wanted to club everything under categories, category A, category B, category C. And the reason why they wanted to do that was because they wanted to bring about harmony in the universe. They said that the universe has harmony. You can classify things, you can categorize things, and they would categorize sour tasting substances as acidus. You'll learn about acid, bases, and salts later on, but the things that would taste sour, they'd call it acidus. The things that would, taste bitter, they'd call it alkali. You'll study that later on in acid, bases, and salts, but they wanted to categorize things. And when they looked at different substances, they looked at a chair, they looked at a table, they looked at a human being, they realized that they can't be bothered by saying a chair is a chair, a table is a table, a laptop is a laptop, a book is a book, a shelf is a shelf. They do not want to use these terms. So what they did was they came up with this beautiful term called matter. What is matter? Matter is literally anything which has a mass and occupies a certain space. It must have these two qualities. An atom is a matter, effectively, is anything which has mass and occupies space. And let me make you visualize this for a moment. Look at yourself. Mustafa, Rabaya, Rayan, Sheeta, Saif, everybody look at yourself for a moment. And ask yourself whether you guys have mass. Do you all have mass? Yes, you do. Because when you stand on a top and balance, or when you stand on a weighing machine, it gives you a particular mass. You have substance, you know. And do you occupy a certain space? Do you occupy a certain volume? Yes, I do. So can I call myself matter? Can I call myself matter? Absolutely. So all humans are what? All humans are matter, literally. Everything and anything around you is matter. Look at the table, look at the chair, look at the books. They all have mass. They all occupy space. They all have volume. Can I call them matter? Yes, absolutely I can. My question to you guys, can I call air as matter? Can I call air as matter? Can I call air as matter? Yes, no? Yes, no, yes, no, yes, no. Is air matter, guys? Yes, obviously air is matter, because although you can't see it, but if you condense air, if you have it in the liquid form, it will have a certain mass, and you can measure it even. And it has a certain volume. Even in the gaseous state, it has a certain volume. So air, because it has mass and it occupies a certain space or a certain volume, it is also known as matter. Yes, makes sense, right? So everything and anything, if you look at a cup, if you look at a jar, if you look at a book, it's all matter. Why? Because it has two qualities. It has mass and it occupies a certain volume. It occupies a certain space, right? Sounds good? Now, my question is happiness. Is happiness matter? Happiness, sadness, abstract, feelings. Yes, bacteria, Hawa, even bacteria is matter, because although you can't see it, Hawa, it does have a mass. Be it nano kgs or nanograms, we don't care, but it does have mass, So anything which has mass and occupies space or takes up space, that's matter, irrespective of whether you can see it or touch it or feel it. But my question to you guys is happiness matter? Is sadness matter? Is anger matter? It's not. It's not matter. Why? Because you might think, oh my God, sir, in my brain, it takes up space in my brain. When I'm angry with my mom, when I'm angry with my dad, it takes up space in my brain. But does it have, okay, I'll second you with this when you say it takes up space in your brain and you can feel it, but whatnot. But can you actually measure it? Can you actually quantify it? You can't measure happiness, What's the measurement of happiness? I am 10 kg happy today. We don't say things like that. That's absurd. That's kind of, some people would say we are un poco loco, right? So happiness is not matter. Sadness is not matter. It's abstract. They're all feelings. So till now, we've learned that matter is what? Is anything which has a mass and occupies a certain space. Your iPhone, your table, your chair, you guys, everything and anything that has a mass and occupies space is matter. Because scientists were just tired of calling chair, table, human, book. They categorized it under one term called matter. And they said, wait a minute, the teeny particle that makes up matter is called an atom. And that's why at the start of this class I said that an atom is in fact the basic unit of matter. What does the basic unit of matter mean? It means that it's the smallest tiny particle which makes up human. It's the smallest tiny particle which makes up iPhone. So if I ask you, what's the smallest particle that makes up iPhone? You guys are going to say, hey sir, the basic unit of matter, because iPhone has a mass and it occupies space, it's matter, and the basic unit of matter is an atom. And obviously this idea is not true in its entirety. I'm not saying that whatever I'm saying right now is 100% true, because there are a lot of exceptions in science, and as we move forward, you are going to properly understand what an atom is. But for now, just realize that it's the teeny tiniest particle which makes up matter, right? Sounds good. Any questions up until this point? Because I'm seeing everybody's questions. Oh sir, samajh aa raha hai. Oh wow, that's great. I like it. Okay, fun fact, guys, and that's why they say that don't trust atoms, because they literally make up everything. Don't trust atoms because they literally make up everything. Yeah, because they make up matter. And the thing that marvels me the most, let me tell you guys, the thing that marvels me the most is how beautifully the Lord has manufactured us. Literally, let me tell you guys something. The number of atoms in our bodies, the number of atoms in a single human being body exceeds the total number of stars in the universe. The total number of stars in the universe, in the entire universe, in one body, one baby body, one adult body, one human body, the total number of atoms exceed the total number of stars in the entire universe. You know how many atoms do we have? We have about 2.14 sextillion atoms. You know how much that is? That's basically a 1 followed by 24 zeros. You could write it as 1 into 10 raised power 24. So it's basically 2.14 into 10 raised power 24. That's how many atoms we have. Do you want to quantify it even more? Not 24, actually 21. My bad. It's 21. Do you want to? It's like a billion trillion. A billion trillion atoms are in a single human body. It's more than all the stars that you have seen or that you have observed in the entire universe. And it's so strange. Science is so strange, because at the beginning of time, that's something that you should think about. At the beginning of time, you know how many atoms there were at the beginning of time? 0. There were no atoms. There was nothing, no matter, no atoms. If there were no atoms, obviously there was no matter. Because matter is made up of atoms. So at the beginning of time, at the beginning of our universe, there were 0 atoms. But now I'm saying that there are a billion trillion atoms in a single human body. And now, if you started counting atoms, let's start counting atoms. If you started counting atoms, and let's suppose I give you a super ability to count 1 billion atoms every second. Let's suppose you had a Superman ability to count 1 billion atoms every second, which is impossible. But let's suppose you were all Superman and Batman and whatnot, and you guys had this ability of counting atoms, and you counted at the rate of 1 billion atoms per second. You know how much time it would take you? It would take you more than 13.8 billion years. It would take you more than 13.8 billion years to count the total number of atoms in this universe. So beautiful. But fun fact, again, at the start of our universe, at the start, can you scroll up? Sure. At the start of this universe, do you know how many atoms we had? Unzer, 0. So how did we transition from 0 atoms to uncountable atoms, billions and trillions and trillions and trillions and trillions and trillions and trillions? मेरा tape फंस गया. And trillions of atoms. How? What happened? How was matter created? How were atoms created? What actually happened? That's basically called the Big Bang. Something known as the Big Bang happened how many years ago? 13.8 billion years ago. And that's the start of your universe. This 13.8 billion years ago was the origin of mankind. Not just mankind, but the entire universe. That's what science believes. Yeah. And before I talk about the Big Bang and how the world was made and how the atoms were made and then how matter was made, do you guys know what the difference between planet and galaxy and stars and solar system is? Or do you want me to tell you? Do you guys know that? Or do you want me to tell you? You guys don't know? Yes or no? Ahmed Shafiq knows. Does anybody else know? Okay. You want me to tell you? Okay. We want you to tell us. Okay, I'll tell you. I'll tell you. Hold up. Hold up. So let me just add a picture. Let me see if I have a picture. Let's see. Oh, yes, we do. See, that's largely the difference between planets, solar systems, and galaxy. Let me just talk about them one by one, just a little bit, so that you guys have an understanding of how tiny you are compared to the entire universe. Basically, planets, if I put it short, you guys can research on your own if you are curious about astronomy and astronomical objects and whatnot. But planets are basically objects, heavenly objects, which orbit stars. That's it. Planets are objects in space which orbit stars, right? So simple. And what are stars? Stars are basically giant balls. Giant balls of what? You guys have studied this throughout your life. They're giant balls of hydrogen gas and helium gas. You know? Just like your sun. Your sun is also a star. You know why? Because it's a giant ball of hydrogen and helium gas. And your sun is so huge. Your sun is so huge. Do you know how many Earths it can fit? Your sun can fit about 1.3 million Earths. You know how much 1.3 million is? It's like tera lakh. 1.3 million is tera lakh. 1,300,000 Earths can fit into a sun. Into our sun, obviously. So huge. It's about 300,000. It's about 300,000 times heavier than the Earth. Wow. Just gas. It's just giant ball of hydrogen and helium gas, and it still is about 300,000 times heavier than your Earth. You know? So heavy. So heavy. The Earth is like a tiny spot compared to the size of sun. Yeah, obviously in your sun it's about 74% hydrogen, if I'm not wrong, and about 25% helium. That's about, and the other 1% are other elements. We're going to learn about them slowly and gradually. But that's largely what stars are. There are even bigger stars than the sun. But you need to understand that planets, they orbit stars. Planets are just heavenly objects which orbit stars. What are stars? Stars are just giant balls of hydrogen and helium gas, and they're huge compared to planets, right? Now, what is a solar system? You must have heard about the solar. पता नहीं आपके elementary teachers ने क्या किया है, कुछ नहीं पढ़ाया. लेकिन let's just talk about the solar system. What is a solar system? A solar system is a group of planets and other bodies that revolve around a star. That's what makes up a solar system. So when you talk about a solar system, it's just a group of planets, not a single planet, but a group of planets, along with asteroids and rocks and whatnot, smaller other dwarfs, whatnot, but a group of planets essentially orbiting a star. And it's shown here. This is a solar system, which means that these tiny dots that you see, these are a group, these group of planets which are orbiting the star. There are other substances as well, but we just care about these planets. So a solar system forms when a group of planets orbit the star. How many planets are there in our solar system? Does anybody know? Yeah? Yeah, you're right, Haisam. Awesome. 8. Yes, it's 8 and one dwarf planet. Yes, you're right. So we have 8 planets. अभी पहले Pluto भी होता था, अब नहीं है. Pluto के Neptune, you guys can check that out later on. But now we have 8 planets in our solar system, and there are countless smaller bodies such as dwarf planets, जैसे किसी ने कहा, asteroids, comets and whatnot. And if you're interested in physics, that's the job of the physics teacher to talk about these things, and you guys can also research onto YouTube if you want to know more about astronomy and astrology and stars and planets. But largely speaking, planets orbit stars, and when a group of planets, they orbit a star, that's what makes up the solar system. And then what is a galaxy? What is a galaxy, everybody? A galaxy is a huge collection of gas, dust, and billions and billions and billions of stars. So it's just billions and billions and billions of stars and gas and dust, and their solar system makes up a galaxy. They're all held together by gravity. And by the way, which galaxy do we live in? Which galaxy? We live in the Milky Way galaxy, right? Now, fun fact, everybody. Let me just show you how small we are. Galaxy. Oh, spelling pathetic. Galaxy. Yeah. Now, what is a galaxy? A galaxy is huge. It has about a single galaxy. If I talk about the Milky Way galaxy, the one that we live in, a Milky Way galaxy has about 200 billion stars. And if there are 200 billion stars, you'd realize that there are at least 200 billion what? At least 200 billion solar systems. What is a solar system? When planets orbit the stars, that means that you have billions and billions and billions and billions of what? Planets. Billions of planets. That's how small we are. And we live in a single planet called Earth. And even above galaxy is your universe. Fun fact, universe has billions and billions and billions of galaxies. Ab sochein how tiny we are. Just think about it for a moment. Let me just consolidate everything. Yeah. So, it's not a part of your syllabus. All of this is just to teach you guys, what science actually is. So your universe is everything. All of space, all of matter, energy, time, everything, stars, galaxies, everything comes under the umbrella of universe. And a universe has billions and billions of galaxies. And each galaxy has billions and billions of stars, And each star has its own solar system. And each solar system has a group of planets. Let me even show it to you. So we have the universe has billions and billions of galaxies. Galaxies have billions and billions of stars, which means there are billions and billions of solar systems. And a solar system is formed when, a group of planets orbit the star. It's not just the sun, which is your star. You have billions of other stars as well. So when a group of planets orbit a star, that's called a solar system. And in one galaxy, there are billions of solar systems. And in a particular solar system is where we humans live. And in that solar system, we live in a planet called the Earth. That's how much small we are. So I do in fact believe in aliens. I do believe in extraterrestrial bodies. And so should you. Because look at the vastness of this universe. So huge. This means that there are many other creatures in the galaxies. How possibly, this is I will also, if you guys, believe in religion and whatnot, at the end of the class, I'll also give you, a story in which our prophet Musa, he once thought that there's no one like him. And then God showed him that there are many, 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 many Musas out there. He showed him, and you guys can see that story. And this is the proof of it. Einstein says that, I think Einstein, or I don't know which scientist said that, but if you have in-depth knowledge of science, it'll make you want to believe in religion. Because there's no such explanation. And you know what happened? 13.8 billion years ago, nothing existed. 13.8 billion years ago, nothing existed. Nothing. Or maze ki baat, how much of the universe can have humans observed? Or can they observe? How much of the universe have humans observed? Only 5%. Us humans have only observed 5% of the universe, which we call observable universe in science. So the observable universe is only 5%. 95%, we don't even know what's going on. We literally don't even know what's going on. Yeah. So that's just beautiful. So if I were to consolidate things for you guys, let me teach you what I've said up until now. What I've taught you guys is that we are just nothing when it comes to the entire universe. But I said that an atom, for now, just realize, is what? It's the basic, what? It's the basic unit of matter. The tiniest particle that makes up matter. What is matter? Matter is anything which has a mass and occupies space. All of us are matter. And then I told you that 13.8 billion years ago, nothing existed. Nothing. How many atoms were there 13.8 billion years ago? Zero. So the question is, how were these atoms made? And before I teach you how all these atoms were made, I taught you guys something, related to planets, related to stars, related to solar systems, and related to galaxies, and then obviously your universe. Yeah? Sounds good? Makes sense, everybody? Makes sense. That's beautiful. Lovely. Yeah? We're so tiny. And then inside one planet is where hum paaye jate hain. Earth. Earth is the planet. Earth is the planet where we are from. I think maza aa raha hai? Yeah? Getting an idea of what chemistry actually is. Now the question is, how did we transition from zero atoms to now uncountable billions and billions and billions and trillions of atoms? You want to know that? That is something known as the Big Bang Theory. Yeah, the Big Bang Theory. Something known as a giant explosion. This is what science says, not me. I wasn't present 13.8 billion years ago. But this is, and neither were you guys, none of us were present, but through analytical measures and through different techniques and whatnot, they figured out that, and now, even now, scientists are starting to object this theory, but largely speaking, we'll talk about this theory, which is called the Big Bang Theory. The Big Bang Theory. There's also a season, if you've watched it, where there's Sheldon, young Sheldon. So scientists believe, how did we go from, this theory explains how we went from zero to bajillion atoms. This theory explains how the universe was made. This theory explains all of that stuff. We're not going to go into a lot of detail and a lot of depth when it comes to this theory, but I'll give you upar se ideas, because it's a very, very complicated and complex theory. So I'm not going to go into that. I'll just give you enough knowledge so that you guys remain curious, if you want. Do you want to know that or no? You just want me to jump straight into the syllabus? From tomorrow, we're going to start the syllabus. Don't worry. Today is just fun stuff. Fun things that I want to share with you guys. Yeah? You guys want to know? Because I'm going to be motivated by you guys. If you guys want to know, I'll tell you. If you guys don't want to know, I'll not tell you. Don't worry about it. I won't bore you with these things. Yeah, Momina is saying, I want to know. All of us want to know. Okay, let's talk about it. So, basically, there's a concept of unified force. What do we mean by unified force? Scientists, I'm going to cut the complexities out of it, don't worry. So, scientists, what they thought was that initially, when there was nothing, shunne, nothing was present, initially, everything was uno. All the forces were one. The gravitational force, the electromagnetic force, all the forces that you study in physics, in chemistry, throughout your lives. If you plan to pursue science, throughout your lives, all the forces that you study, scientists say that initially, when there was nothing, everything was one. It was just one force. And then for some reason, nobody knows why, but for some reason, 13.8 billion years ago, a huge explosion happened. Huge. Big ass explosion. And this explosion caused a lot of chaos. There was just energy everywhere. There was energy. The entire universe, after this explosion, there was just energy, chaotic energy. the entire universe was just drowning in sea of energy. Lot of energy. Very chaotic. You know, not tamed, untamed energy. That's what it was. The universe was very dense, very hot, and just energy everywhere, everywhere, flooding every corner of space, everywhere. But then what happened was that when this explosion happened and there was a lot of energy, universe started to expand. Universe started to expand. It's still expanding, but the universe after this explosion started to expand. You know, like you study something which is hot, it starts to expand. If you've ever cooked popcorns, if you've ever made popcorns in your microwave, do you see when it gets hot, it starts to expand? The entire bag starts to expand because the hotter things get, the more they expand. You know, or you've studied this in your elementary physics that hot air starts to expand. And what happens is when things start to expand, when hot things starts to expand, it also starts to cool. When something starts to expand, it also starts to cool. So this entire energy after this explosion happened, all this energy was already there. All this energy was there. And the universe started to expand. Expand. And when the universe started to expand, obviously it started to cool. And as temperature dropped, if something cools down, obviously you know that the temperature starts to drop. So when the temperature started to drop, the energy started to transform into tiny particles. I'm skipping the complexities. So this energy, when things started to cool down, this energy started to transform into particles. And you learn that if you pursue physics, theoretical physics in your career, but the energy started to transform into tiny particles. How can energy do that? It can do that because of E equals mc square. You'll learn more about it. You've all heard about E is equal to mc square. If you're not, you'll learn about it later on. But this energy started to go into tiny particles. And through this, the first particles were made, which were your protons, neutrons, and obviously your electrons. They were all made of energy. The first particles were made. A single proton was made. And the first element that formed was a hydrogen element. The element hydrogen, because it's a single proton. So the first particle to ever be made, the first particle inside an atom out of protons, electrons, and neutron was in fact the proton. So the protons were made, and then a few minutes after the Big Bang happened, the electrons were also made, and then the neutrons were made alongside the protons, and they were made from strings of energy. It was just energy. And because temperatures started to cool, they started to convert this energy into tiny particles, made the first proton and the first neutron. And then a few minutes after that, electron also formed, more of which you will study later on in this syllabus, right? And the first element to form was the hydrogen element. Yeah. But realize that an atom was still not formed. The protons, electrons, and neutrons, they were just roaming around in space. They were all everywhere in space. They were, just spilt. They were spilt, flooding space. The atom was not made. Because we know an atom is made up of proton, electron, and neutron. But when these particles were formed, the atom was still not made. Then how did these particles go into the atom? Well, what happened was that their scientists, they think that because these particles were just roaming freely, the proton was in the east, the electron was in the west, the neutron was in the south pole, and some energy was required to bring them all together and make it into an atom, which is the atom of hydrogen, right? So how was the atom of hydrogen formed? Some energy was required to bring the proton, electron, and neutron together to make a beautiful atom. And that happened almost 380,000 years after the Big Bang. So after the Big Bang took place, 380,000 years after that, some energy, we call it the Great Attraction. The Great Attraction. The Great Attraction took place and brought together the protons, electrons, and the neutrons. And the first atom was formed, which is the atom of hydrogen, obviously. And then the atom of hydrogen fused together with other atoms, another atom of hydrogen, and then it made, another hydrogen atom, and then so on and so forth. The helium atom was made, and then from the helium atom, the lithium atom was made, and that's it. Only 3 atoms were made initially. Maze ki baat, abhi to we know that if you look at your periodic table, you have hundreds of elements in your periodic table. But initially, after the Big Bang took place, you had protons, electrons, and neutrons, and 380,000 years after the Big Bang, they converted into the atom of hydrogen. And then this atom of hydrogen combined with other atoms of hydrogen and neutrons and protons, and it made the atom of helium, which fused together to make the atom of lithium. But that's it. That's about it. That's it. That's all the elements that were there. Then your question should be, sir, but in the periodic table, there are so many atoms. How was carbon made? How was oxygen made? How was nitrogen made? How was iron made? How were all of these elements made? Well, what happened was that after these elements were made, they all combined to form a star. Because you realize that stars are what? Stars are just giant balls of hydrogen and helium gas. It also has traces of lithium, but they're just giant balls of hydrogen and helium gas, right? So when stars formed, they started to make more and more hydrogen and helium and hydrogen, but they did not have enough energy to make these beauties. They did not have enough energy to make carbon, oxygen, nitrogen, iron, and da. They did not have that much energy. Then how did these elements form? Well, what happened was that because these stars were continuously making hydrogen, helium, they were using up their energy. The energy of stars, or you could say the fuel of the star, was being used up. Nuclear fusion is the technical term used for it. Nuclear fusion was taking place. These atoms were being fused to make more and more and more and more. So the energy of the star was finishing slowly and gradually until it reached its death. Do you know what the death of a star is called? Do you know what the death of a star is called? What is the death of a star called? Sir, Abdul Samad of Pakistan got Nobel Prize of this unified force theory or so called theory for theory. Yes, you're right. Abdul Salam, not Abdul Salam. Do you guys know what the death of star is called? Nobody knows? It's called supernova. So the star, it gave out energy, continuously made hydrogen, helium, but then it reached its age. Buddha ho gaya. It reached its age, near its death, and when a star dies, it's called supernova. A huge explosion once again took place. Explosion. Huge. And this time, this explosion had enough energy to fuse, to combine all these atoms to make these new atoms or to make these new elements. And that's how all the 92 elements of your periodic table were made. Nowadays, there are 118 elements in the periodic table, but 92 elements are the ones which were initially made. 118 because all of the other elements are humanly. You can also make elements. They're very unstable. You'll learn more about it later on in A-level chemistry. But the initial elements that were made were 92 elements. The first 92 elements of your periodic table were made. And nowadays you could say there are 118 elements, but after 92 elements, the others are just artificially made from human beings, And so in summary, if I talk about this entire idea, I said that your entire universe starts with atoms, and I'm going to wrap it up in a bit. So your entire universe started off with atoms, and we said that atoms were the basic unit of matter. And then obviously we weren't able to properly understand what an atom is and what we mean by basic unit of matter. But we firstly understood what matter was. Anything which has a mass and occupies and occupies space. So the tiniest particle that has mass and occupies space is the matter, which obviously has mass and occupies space. The teeny tiniest particle which will make this matter up is called an atom. Yeah? And then we realized that initially we had 0 atoms. Now we have a lot of atoms, but initially we had 0 atoms. Where did all these atoms come from? All these atoms came 13.8 billion years ago, when a huge explosion took place called the Big Bang. And from the Big Bang there was a lot of energy, floods of energy in space. But because it was just flood energy, this energy made the first particles called protons, electrons and neutrons. This is basically a few minutes after the Big Bang. And then fast forward, this was not an atom, because a force was needed to combine them into an atom, and that force came 380,000 years later, called the gravitational force. So that gravity actually clumped these three together to give you the first atom, which is the hydrogen atom. And then this hydrogen combined with hydrogen and other protons and to give you helium and lithium. But there was very few traces of lithium, very few, less than 1%. But there was not much energy left to make all the other elements. So what happened was, gravity actually clumped the hydrogen, helium and a little bit of lithium to give you stars. And these stars continued to make hydrogen and helium and lithium, hydrogen, helium, lithium. But it reached the end of its life, called supernova, which is a huge explosion that takes place after a star dies. And this supernova actually gave you the other 92 elements, and this in fact formed all the atoms, all the planets, everything. So that's the connectivity there. That's literally what we've done up until this point. That's literally what we've done. And fun fact, when we talked about, when I said that, there's something known as carbon, oxygen, nitrogen, what are these things? You'll learn more about this throughout the course. But we see them in our day-to-day lives. If I talk about oxygen, the atom oxygen, you literally inhale it. You literally inhale oxygen day to day in the form of O2. That's what keeps us alive. And fun fact, it's the same oxygen that is responsible for our deaths. ये मैंने बड़ी deep बात कही है. Some of you may not understand this as of now. You guys may think, oh, oxygen is required for all living things, oh my god, but you'll realize later on, if you are like, 40s and in your 40s and 50s and you continue to pursue science, you'll realize that it's the same oxygen which causes us to die, But for O-level IGCSE sake and for A-level sake, we'll just say oxygen helps us breathe. It helps us, not breathe, but helps us stay alive. And the same oxygen is given out in the form of carbon dioxide from our bodies. That's called respiration. So it's the same elements, just same atoms, just different combinations of the same atom. Some can be toxic, some can be useful. It's just different combinations of these atoms which have made the entire universe. That's it. Our human bodies, our laptops, our iPads, even the cell. When you study in biology that cell is the building block of life, well, hold up, biologists. Cell is not in fact the building block of life. Something else makes up a cell, as called atom. So, and because cell also has a mass and occupies space, although you may not be able to clearly see it, but that's the reality of things. How does it cause death? Well, Mariam, it's too complicated. I won't go into a stupid question. Hawa, no question is stupid. Don't worry. How do scientists claim and made up such concepts when they weren't even there? Hawa, that's such a beautiful question. How do you say it's a stupid question? It's a beautiful question, Hawa. Well, scientists they use estimation, Hawa. So just like dinosaurs, you weren't there millions and millions of years ago when dinosaurs were around, but it's called something known as carbon dating. So they use different techniques and different estimations and calculations to figure out that this might have been the case. But what is the reality behind things? Nobody knows. Nobody knows. It's just all of these explanations, all of this ideology, this theory, the Big Bang theory, tends to satisfy humans. It tends to, just give you a food of thought, acha haan, aise hi hua hoga. But if you're a good scientist, maybe you figure out that something else was there. Nowadays, I was reading a research paper and an article as well, and they were claiming that the Big Bang theory is not true in its entirety. So science is ever evolving. It always evolves. It always changes. I can't give you up-to-date knowledge about black holes and because that's very complicated. If you want to defy theories, you first of all have to understand basics. So I'm going to give you the basics, and hopefully if you pursue science later on as a career, then maybe you start to defy the theories. It's so beautiful, yaar. Maza aaya वैसे. We're all connected. And fun fact, everybody. One fun fact. I forgot to tell you guys this. How old are you? Everybody's going to say, I'm 15, I'm 16, oh my god, sweet 16 and whatnot. But in reality, do you know how old you are? You guys are, let me write it. Wait. You guys are 13.8 billion years old. Why, sir? Why are we 13.8 billion years old? Because at time equals zero, when there were no atoms and the Big Bang took place and the atoms were created, those are the only atoms created. Uske baad, no more atoms were made. That's why you must have studied this in your elementary classes, that atoms can neither be created nor destroyed. Atoms can neither be... But they were created at one point in time. After that, now we say atoms cannot be created, neither can be created, nor can they be destroyed. So you guys are actually stardust. You guys are made up of stars, because the same atoms that came out of the star when it exploded are the ones which makes this universe, which makes you guys up, which makes the planets. So beautiful. So we all are connected. We're all connected somehow. Don't be mean to each other. Don't bully each other. Don't be like, oh my god, Bushra, tumhe to main Sir Salman ke baare mein bataungi nahi, I'm just going to enjoy the class. But yeah. Haitham is saying, sir, too much oxygen for our body can result in hyperoxia, which is it's not just about too much oxygen, Haitham. किसी दिन आपको बता दूंगा कि मैं क्यों कह रहा हूँ. But that's probably it. Let me also show you my face. Some of you ऐसे शक्ल दिखा दें, मुखड़ा दिखा दें. दिखा देता हूँ, देख लो यार, मेरे मुखड़े से आपको क्या मिल जाएगा, देख लो, नज़र आ रहा हूँ, खुश हो आप लोग हैं? Let me show you. Okay, great, happy, awesome. Guys, did you guys enjoy the class? Just looking like a wow. You guys enjoyed this? So आज की क्लास में हमने कुछ भी नहीं पढ़ा. It was just, and some of you might have also gotten scared after getting all of this, after trying to absorb what I have done here. अच्छा, मैं notes ऐसे नहीं देता, ये बहुत गंदा मैं इसलिए लिख रहा हूँ, it's rough, it's just I was going with the flow. But notes अच्छे होंगे, टेंशन ना लें. मतलब मैं जब लिख रहा हूँगा तो आपको समझ आ रही होगी. This is just going with the flow. I'm sorry guys. I know it's rubbish. I know बहुत गंदा लिखा हुआ है. But I hope you got the idea behind things. So if you guys enjoyed today's class, and if you guys were scared, don't worry. Tomorrow, कल से O level IGCSE chemistry शुरू होगी. आज सिर्फ थोड़ा सा ना, मैं दिल चाह रहा था आपको थोड़ी सी. I skipped on a lot of things. Things related to how the Earth was made. A planet called Theia collided, and then things happened. There was a disk that was revolving. बहुत चीजें मैंने skip कर दी, क्योंकि I figured that some students may just get scared. So none of this was a part of your course, guys. Don't worry, those of you who are worrying. But tomorrow we are going to start off with the first chapter of your O-level IGCSE chemistry, as called State of Matter. Actually, fun fact, Fun fact, one more fun fact. Um, do you guys know that although we realized that atoms were created 13.8 billion years ago, do you guys know how humans came to know about it? Do you guys know that? Do you guys know how humans came to know about atoms? No? We'll also talk about that tomorrow when we start off with the first chapter and I start linking things to your O-level IGCSE chemistry. But humans, for a very long time, did not know about atoms. How did we know? Well, that's a story for another day. But I hope things made sense, you know. Atoms, basic unit of matter, which is not true in its entirety, but for now I'll just say basic unit of matter. Matter is Big Bang, energy, proton, neutron, electron. First atom was formed, stars formed, supernova, stars died, more atoms formed. And that's it. Do you guys want to ask questions? Sure, you guys can ask questions.